Hello everyone. Let's discuss another Leetcode problem. And today's problem is permutation in a string. This is one of the problems in the blind 75 list. So let's go to the problem description. We're given two strings S1 and S2. We have to return true if S2 contains a permutation of S1, or if S2 doesn't contain a permutation of S1, then we return false. So what is the permutations? You know that, say, if we have something like a string ABC, one of the permutations are like BAC, right? Or it can be CAB. So permutation means, in other words, we can say permutation means anagrams, right? Okay, so we have to find the anagrams. In other words, we have to return true if one of S1's permutation is a substring of a S2. Okay, so contains means these three letters not only has to be in S2, say this is S2, it has to be a substring. That means they have to be contiguous. Okay, so they have to be contiguous. So contains means they have to be contiguous. So suppose if we had like BAC here, then we say yes, S2 contains the permutation of S1. Okay, so let's look at the first example here. First example, S1 is AB, and the second string is this EIDBAOOO. So we have to find out if S2 contains the permutation of S1. So first thing, you see that the second one has to contain the first one, right? So we find the edge cases. Let's try to find the edge cases. So the edge cases are, you see that the size of like length of S1, if length of S1 is greater than length of S2, then we cannot, there is no chance that S2 will contain S1, right? So that's a case that we have to check first, because if S2 contains a permutation of S1, then S2 has to be at least the same size of S1. Otherwise, S2 cannot contain S1. The second thing is, if you see, if S1 is an empty string, then we return true. The reason is like any string S2 contains the empty string, right? Okay, so but for this example, obviously you have to ask the interviewer. For this example, the length of the strings are at least 1. Okay, so we don't need to check this case, the second case. So we found the edge cases. And another thing is S1 and S2 consists of only lowercase English letters. This is also something that you need to check with the interviewer. Okay, so let's look at the first example. So you see within S2, we will check the substring that has the same permutation of S1. So how can we do this? Okay, so let's think about this, and let's take some, you can pause the video here, let's think about it, and then you can come back and we can discuss the solution together. Okay, so I hope many of you already have thought about a solution. Okay, so let's think about a very nice solution. Why don't we do this? We count the characters in S1, right? And then we can just check every substring in S2, right? So we can check this substring, and then we can move on and check the next substring, right? So we can just keep on checking like substrings of size 2 and see if the character count within that substring matches the character count within this substring, right? So we can keep on doing this, and if there is a match, then yes. So you see, A has a count of 1 and B has a count of 1, right? Okay, so let's try this substring. No, right? It doesn't match. So we just move it. Let's check the second to, no, it doesn't work. Then let's check DB, right? The character counts don't match. Next, we check BA. Now you see the character count within this substring actually matches the character count here. So we can return true. So this is a very easy way. And let's see what is the time complexity of this algorithm. So if this is L1 and if the length of this string is L2, so you see how many times. So every time uh, we are just moving our kind of sliding window of size L1, right? So we are taking a substring of size L1 and then checking again, we are taking the substring of L1. Okay, so how many times we can move the window at most? So there are like L2 characters here, right? So L2 characters, for each of them, if this is the starting point, then we go L1 of length L1, right? We take a substring of length L1. Then from the second one, again, we go and take a substring of L1. That means for L2 characters, for each of them takes a substring of so each of the characters is a starting point for a substring of length L1, and then we make like L1 number of comparisons, right? Okay, so for each of these characters, we start a substring and make like L1 comparisons, right? So this is the total number of comparisons we may have to do in the worst case. So this is going to be the uh, time complexity. Okay, and to make it more accurate, let's see. Actually, we don't start the substring everywhere. We actually stop somewhere, right? So we stop uh, when there is like L1 distance from the end, because beyond that we don't have a substring of size L1. So basically, it will be L2 minus L1 starting points, and so these many starting points, and for each of these substrings we make L1 number of comparisons, right? Okay, so this is the time complexity. Space complexity is we are not actually using any extra space. The reason behind that is, you see, we have used a map to take the frequency count, right, of L1. Now you see that since we have lowercase English letters, that means this map can be at most 26. Uh, the length of this map uh, cannot exceed 26. So that means L1 is 26. So order of L1, that is, uh, which is order of 1. Okay, so this is the time complexity. Okay, so let's see. And already by now you see that this is a sliding window problem. So let's see if we can solve this problem with sliding window. Okay, so let's take a look at this problem in a different approach. Let's try to use sliding window to solve this problem. So in a sliding window, it means that we'll slide our window to the second string, say this, right? And try to see if uh, the character frequency of this matches with the character frequency of the S1, right? So this is S1, and this is substring of S2 inside the sliding window. We'll try to see if the character frequency matches. Okay, so say this is a string S1 and this is a string S2. Let's try to solve this in a different approach using sliding window. So what we are going to do is we are going to slide a window through this string, right? And a window is at any point is going to contain a substring of S2. Say this is my current window, right? So what we're going to do is we will try to see if the frequency of the characters inside this window matches the frequency of the characters in string S1. Okay, so we have to keep track of the frequencies. So the first thing is we have to keep track of the frequencies. For that, we need a map. We'll populate this map initially with the frequencies of a string S1. You see, we have A one time, we have B one times, C two times. And so we call it map 1. And then we are going to have another map to record the frequencies of the characters inside the current window. Okay. Now you see this window is going to, we need to expand and shrink this window, right? Because this window is going to be get invalid from time to time. So it will either expand to the right, that means we have to increase the window, right? And sometimes we have to shrink it. So if it becomes invalid, we have to shrink it further. We have to make this, and then we expand again, say we expand, and then we shrink, right? We shrink. So we will keep on doing this. So, and we have to keep checking when the window is gets invalid. But our final goal is to make sure that getting such a window, or getting such a window where the frequencies of this window is going to be same with the frequency of the other window, frequency of string S1, right? So this is our target. Okay, so this is consistently changing in map 2. And the other thing is, every time just checking every character if they match or not is a little bit cumbersome. So for that, what we can do is we can use a clever technique that we can just keep a variable, say required. Required means how many characters we need to match. So when you are actually populating this, we can count that required is 3. And then we can have another integer formed. Formed means how many of these required characters have been found so far in a window here, right? We'll say formed initially 0. When formed becomes 3, say we found a window here. Just say I'm randomly saying like this is one of the windows, say. Okay, so we found it here where we have 3 formed characters, and that matches the required. That means we have found all the required characters within the window or within that substring. Then we have our result as true. Okay, so let's start. By the way, this was just a theoretical window, not necessarily this is our result. So let's try to simulate this and see what happens. So initially we are you're populating this map 1 with the frequency, and required is going to be the size of this map. Okay, so required is going to be the size of this character map. So this is how many characters we require to match, right? Now let's start the window. So you see we are going to have like 2 pointers, the left pointer and the right pointer. So this is the left, and say this is the right pointer. Okay, so initially both of them are going to point to this, right? Okay, so they're both going to point to this. So we take the frequency A1, and you see that initially the formed is 0, and we update the frequency of the window. So this is our window right now. Okay, this is our window. So the frequency matches, and you see already it matches. So that means we have already found one character. So the one character is there. Next, to expand our window to E, right? So the right pointer is now pointing to E. But what happens is, if we do this, actually that's not going to help us anyway, right? Because we cannot simply have an invalid character in our window, right? Because the window that we're looking for is going to be a substring. So everything inside that window has to be a character of which is already in S1, right? Okay, so if I found something that is, if I find a character which is not in S1, we can immediately say, hey, this window is not going to work. So what we have to do is, whatever you have done, just discard this whole window and start over again, right? So this is the first condition of an invalid window. So invalid character, right? So this, if we have an invalid character, then we just start over again. By starting over means we just whatever we have done, we just leave there. We start over again from here, from the next, okay? And the right is also here. We start over again. And once we start over again, we also have to do, what we have to do is we have to reset the map as well. And then we have to reset the form as well. Everything we reset and we start our window again. Okay, let's try to expand. Now you see I is not in map 1. That means this is again and this invalid character thing. What we have to do is we have to reset. So we have to reset again. We have to start our window again from A, right? And we reset the map. Well, map was already reset, but anyways, if there was in the map, and we reset the form because we are doing it over again. Next, we expand and you see that now it's pointing to A, and that means we have sufficient number of A. So that means form becomes 1. We expand to B. B is, we require 1B, right? And we already have 1B. So this one is a form character, so we increase it to 2. Now we have 2 form characters. Next, we increase it to 2. Now you see, this is a mismatch, right? So now I have more A's than what I want. And actually, I cannot move further. The reason behind this is I cannot have a substring that has 2 A's, right? So that is the second way of a sliding window becoming invalid, right? The sliding window now looks like this, and this is invalid when a frequency of a valid character is more, how we can say, is more than what required, right? In map 2 is more than frequency in map 1. And so we don't afford 2 A's. So that is, again, we say that invalid. But this time we don't discard, because probably part of this window is still useful, right? So we don't discard the whole window. What we do is we start shrinking to make it valid. So what we do is we change the left pointer, right? So the character at left pointer was A. We change the left pointer to 1 space. We make the left boundary to B. We reduce it to 1. Okay. So reduce it to 1. And now you see that what you see now is now this window has the accurate number of, both of them are valid and the formed is still 2, right? Now this is a valid window again because this one is matching, right? This is matching. Okay, so this is the second reason for a window to become invalid. Okay, next we expand right again. This one becomes 2. Now you see this is a mismatch, right? That means the second reason is hit again. So what we do is we try to fix this window by what? By shrinking it further. So for that, what's going to happen is B becomes 0. And as soon as you do that, you see that there's a mismatch. So a mismatch is happening, so formed is reduced by 1, okay? And still you see that the window is not valid, right? Because the frequency of A is still bigger than the frequency of A in map 1, right? Okay, so what we have to do is we have to further change the left pointer. So the right is here and the left is now changed to, sorry, the left pointer is changed to here. Now you see that I changed the frequency to 1. And now this window becomes valid again, right? So this is a valid window. Next, what we do is we change the right to this. C becomes 1. So formed becomes 2. Okay, not 2 because it still C's doesn't have, we don't have enough C's. So we expand. Okay, so now you see B matches, right? The number of B matches. That means we have found 2 of the characters. Next, we expand. You see now this one becomes 2. Mismatch. So this window is not valid anymore, right? This window is not valid anymore. What we have, because we have hit the second condition, what we have to do is we have to try to shrink the window to make it valid. So we change the right pointer. By the way, right pointer already have been here. Okay, so we change the left pointer to C, and A's frequency is changed to 1. Now you see that we have a match again, right? We have a match again. So the window now becomes valid. Okay, so once the window becomes valid, we expand it again. We expand the window again, and this time C becomes 2. There is a match, and form becomes 3, and these two is now equal, so we return true. Okay, so we have found our window, which has a permutation of the characters of S1. Okay, so let's code it. Initially, we have to check the edge case. If the length of the first string is greater than the length of the second string, then there is no way that a permutation of the first string can be contained in the second string, right? Because the first string is itself larger, so we return false. Okay. The other edge case could have been that if the first string is empty, then we could return true, but in the constraints here it says it's not empty. But you have to ask the interviewer. Okay, next we will have to hash maps to track the frequency of each characters, right? So we call it map1 to keep the frequency of the characters of S1, and map2 is going to keep the frequency. We will use this to keep the frequency of the characters in the sliding window in S2, right? Okay, so let's populate map1. So we'll read each character from S1, and we will put it in the we'll increase the frequency of this character in map1. So it might be the first time it's getting inserted into the map. So we use this method. If it's already there, it will return the frequency. Otherwise, it's going to give us 0, and we will add 1. So we are increasing the frequency. Okay, so next, we want to know how many characters we require. That is map1 dot size. Okay, and how many characters that has been formed inside the sliding window in S2. We'll keep track of that. We'll update that. Initially, we'll initialize with formed as 0 because nothing has been found yet. And then this is the left pointer. We point it to the index 0 of S1, and the right pointer. So we'll keep on moving right pointer, right? The right pointer will keep on moving till, in the worst case, it will go to the end. Okay, and then what we're going to do is we are reading from S2, right? We are reading characters from S2. So read one character. We will read the character at the right pointer, and then we'll check if this is an invalid character. If it's an invalid character, then we have to reset the whole window again, right? We already explained it. So if S1 doesn't contain, if this character in S2 is not in S1, then what we're going to do is we have to reset our whole sliding window. That means left will be placed on the right side of the current right, and then we have to like erase everything from map2, right? So we have to erase everything in map2. What we are going to do is you are reading each character key from map2, and putting frequency 0. Not only that, if already we had something formed, we have to also reset it to 0. Nothing is formed. We will just start over again. Okay. Otherwise, and then we will just continue. That means we're done. We will start again, right? We have reset everything. We have started a new window from this left pointer, and then we'll start again. Otherwise, if this condition is not met, that means we have found a character in S2. This character in S2 is already in S1. So what we are going to do is we have to increase the frequency of this character in map 2. So map 2 contains the frequency of the characters in the sliding window, right? Okay. Might be the case that this is the first time this character is being inserted. So we use get or default method. Okay, so now the frequency is updated, and then we have to check if the frequency of this character. Okay, so inside the map we had this integer object, so we have to change it to int to compare. Map1 dot get. So let's see if the frequency of the character in the sliding window matches the frequency of the character in S1, then we say, oh, okay, we found one character that is formed, right? Okay, so if this matches, then we say formed, and then we check if formed is already reached the required. If that is the case, then we say, okay, we found our sliding window that has the same number of characters of the same characters that are in S1, so we are done. We are done, and yes, we say yes, we found that permutation. Otherwise, what are the second reason for the window to be invalid? So the second reason for the window to be invalid is if the character frequency. So okay, so this one is going to map 2. Okay, so we increase the character frequency in map 2, right, in the sliding window. It may cause two things. One is, like, obviously it may cause these things, or it may bring the frequency of that character in sliding window over what is the over the frequency in S1, right? Okay, so if that is the case, we have to fix the windows. This is the second condition of the invalid window, right? So you remember what we did for that. To fix the window, now we started shrinking it. So what we will finally do is we'll shrink it. But before that, what we have to do is we have to remove the character from the window that is in the current left, right? So we identify the character, and then we want to remove it from the map. Okay, so map 2 dot put minus 1. We decrease the frequency, we remove the character from the sliding window frequency map, and then we have to check if okay, so by removing it, one thing that may happen is, okay, so let's check this. So say already this was the case, the character that we are going to remove, right? We're going to remove this character from the sliding window from the left. This character from the left is going to be removed. Now, if already the frequency was the frequency of this character that we are going to remove from the sliding window is already matching the frequency of the character in S1, right? In that case, what's going to happen is, as I decrease this count, this is no longer a formed character, right? So we have to, if that is the case, we decrease formed by 1, and then we do this, right? Because by decreasing this frequency, like we are removing one character to make the window valid, we're removing one character from the left. And doing that may cause a formed character. That means already the frequency was the same. Now the frequency is going down. So we have to reduce the formed by 1 if this is the case, okay? And we'll keep on doing this until this invalidity condition is fixed, okay? So we'll keep on doing this. So fixing the window here, fixing the window, like resetting the window here, the 2 invalid window conditions are fulfilled. And finally, we will just do return false. Okay, so there might be some mistakes. Let's try to run and see. Okay, so this got accepted. I'm not sure. Let's submit it. Okay, so this got accepted. So what is the time complexity of this algorithm? So you see, this one took order of L1, the length of S1. And this one, you see, we move the right pointer like maximum of L2 times. And we also move the left pointer maximum of L2 times. So order of L2, and we are not, okay, and that's it. So order of L2. So the time complexity of the algorithm is order of L1 plus L2. That is it, okay? So thanks for watching, and hopefully next time we will come back with another problem. It might be a sliding window or another problem, but hopefully if you have watched other sliding window problem, you have already built up a concept of that sliding window problems have some kind of pattern, right? Okay. Till next time, goodbye.